My warm wishes to everyone. Myself, G. Chandana, graduating from Srinivas Ramanujan Institute of Technology, holding a roll number 234G180-425, and I am from EC department. Today, my topic in this presentation is time averages in random processes from the subject signal system and stochastic process. So, the topic is time averages in random processes. Before going to the introduction to time averages in random processes, first we need to know what is random process. Random process is a random variable at time t. Now let us discuss about the time averages in random process. Time averages are essential in understanding the long time behavior of random processes. They provide a way to access the expected value of process over time. This concept is widely applicable in various fields, including statistics and also in engineering. Now, let us see what is the definition of time average. The time average of random process is calculated by taking the average value over a specified time interval. Mathematically, it is represented as the limit of the integral of process over time. Time averages help identify trends and patterns in stochastic behavior. Here you can see the time averages versus ensemble average. So here we have the formulas of mean, mean square, variance, and autocorrelation. These are the integrated of process over time t. Now let us see what are the importance of time averages. Time averages are crucial for predicting future behavior in random processes. They allow researchers to access stability and convergence in dynamic systems. Understanding time averages aids in the design of control system and forecasting models. What are the properties of time averages? First, now let us see the properties. Time averages are generally consistent across different time intervals for stationary processes. Second one is they can differ significantly in non-stationary processes due to changing conditions. And the third one is the law of large number of underpins the convergence of time averages to expected values. Time average versus ensemble average. Time averages are computed from a single realization of random processes over T. Ensemble averages, in contrast, are calculated across multiple realizations at a fixed point in time. The relation between the time averages and the ensemble averages can yield insights into the randomness of processes. Ergodicity and time averages. The process is termed ergodic if time averages equal ensemble averages over long periods. Ergodicity implies that time averages can be used to estimate the statistical properties of processes. Many physical systems exhibit ergodic behavior, making time averages a useful analytic tool. Here you can see this mean that the mean of a random process can be written as mx is equals to limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t dt. So the autocorrelation now can be written as Rx of tau is equals to limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t into x of t plus tau into dt. These are the formulas. Applications of time averages. Time averages are applied extensively in signal processing to analyze and filter signals. They are also used in economics to access trends in financial markets over time. Other applications include physics, biology, and reliability engineering. How can we calculate the time averages? Now let us see about that. Time averages can be computed using numerical methods or analytic techniques depending on the process. The choice of time interval significantly impacts the accuracy and the reliability of the average. Software tools and simulation often access in calculating time averages for complex processes. Here you can see how to calculate the average. Here we have a data set of 14 values. So all these 14 values are taken sum. that is 690, that is equals to sum total of the data set. If average formula is sum of total of data set by number of values in data set. Here we have totally 14 data sets. So that is 690 by 14 is equals to 49.29 minutes. This is how we will calculate the average. Challenges in time averages. Non-stationary processes can complicate the calculation of reliable time averages. Determining the appropriate time window for averaging is often a subjective decision. Noise and other layers in data can skew the results, necessitating a robust statistic method. Further directions in research. Research continues into developing better methods for estimating time averages in non-stationary processes. Machine learning techniques are increasingly being employed to improve the analysis of time series data. Interdisciplinary approaches are enhancing the understanding of time averages across various fields. Thank you for watching this presentation and thank you for giving me this presentation.